the taxi set fee is $10 and per kilometer is $5 versus a taxi company with a set fee of $20 and per kilometer they charge, let's say, $2. When does it become economical to pick company B over company A? Yeah, exactly though, where? Exactly how many kilometers? After exactly how many kilometers will, because we know that eventually company B is definitely going to be better, but then when we get in the taxi, we're charged more straight away. So, but at which point does it become more economical to switch? Like, you know, if you're going 1 kilometer, it's definitely going to be cheaper for company A. It costs 10 plus 5 is $15. Going 1 kilometer is 22. 4 or so? Five. Okay. So we can solve this using simultaneous equations. Let's say the price for company A is the set fee, 10, plus 5 times the amount of kilometers. Let's call it 5x. And that will give us our total price. And let's say y is the total price. And let's say company B then has the same thing. The total price is the set price plus 2 times the total kilometers. Now, if I find out the place where they are equal to each other, where y is equal to each other, the costs are equal to each other, I can find out where company B then becomes more economical. So I can say, right, when y's are equal to each other, so in other words, I can replace this y with that, or just set these two equations equal to each other, I can solve for x. So company A versus company B, when the costs are the same, I'll know where they're perfectly the same. So how many kilometers in? We can do our algebraic solving here. Minus 2x from both sides, we get 3x. Minus 10 from both sides, I think we get 10. So after, what's that, 10 over 3 kilometers, so x is 3.3 recurring kilometers. That's the point that they would cross over, and that's the place where we'd pick company B. Okay? So this is one way to solve what's called simultaneous equations. What was the thing here? Well, there's actually 2 unknowns. We don't know the total price, and we don't know the amount of kilometers. But we can solve also now for what's the y value? What's the cost at that particular point? What's the cost at 3.3 kilometers? Well, I can sub in 3.3, and we can go y is equal to 10 plus 5 times 10 over 3. And what's that? Give me 10 plus 50 over 3. And now this is the mistake some of us made in the last thing. If I want to add these two together, this one also has to be thought about. It's not over 3, so that'd be 30 over 3 plus 50 over 3, common denominator 3. And I get y is 80 over $3, which is not the way we'd say dollars. So what's that as a mixed number? So 3 fits in 26 times, and remainder, what's the remainder? 2/3? Yeah, it might be 6 recurring, yes. So $26.67. Okay, so what we've done there is this: we've solved simultaneous equations. I'm sure you've come across simultaneous equations before. There's 2 methods to solving simultaneous equations. We can use substitution, or we can use elimination. Which method did I just use? Substitution. Yeah. Yes, that's the substitution method, where I know that y equals, so I can sub this in for the y in the other one and let them equal each other and solve. Let's do another example. Let's use one with no context at all. Solve simultaneous using substitution. So I'm going to do this. We have this equation. We have this other thing, 2x plus 3y equals 21. So we want to solve with substitution. So we're going to do something similar to over here. This is a little bit more complicated, but y is 9 minus x. And I want to see where that y would be the same as this y. So I would replace this y with the 9 minus x. I would substitute in y minus x into this one. So I get 2x plus 3 times, not y anymore, 9 minus x. The same principle as this, where the y's are the same. I find where the y's are the same, and then I can find the x value at that point, and then I can go back and find what the y value was. Just let the y's be the same. And that equals 21. So what we're left with here is just like an algebraic equation like you were solving. There's no more y's anymore, it's just x's. 2x plus 3 times 9 is 27. 3 times x is minus 3x, 21. Like terms can be combined here. So I have minus x plus 27 is equal to 21. What's x going to give here? Anyone got it from this stage? Well, you can subtract 27 from both sides. I think it's going to give 6. So we get minus x is equal to 21. Take away 27, which is negative 6. So x is just 6. All right, so x is just 6. So if this was a taxi company again, after 6 kilometers, these two would be the same. What do I do then? I want also y, because it's a corresponding y value. So I have to use one of these equations, doesn't matter which one, to solve it. This is the easier one, the first one. Y is equal to 9 minus, well, x is 6 now. I just found out it was 6. So y is 3. Visually, what does an equation like this look like if we tried to draw it? It's a straight line, yeah. It's a straight line. So you would have done straight lines like this. What's the gradient of this line? Does people remember the gradient? Lexi knows. No, she doesn't. She's not paying attention. She's getting Chloe's in her ear. 1. Almost. Negative 1. It's downhill. Yeah, negative 1. Okay, what's the gradient of this line? It's negative. Yeah. Get y by itself. Negative 2 over 3, yes. So you'd subtract the 2 over, and then you divide it by this 3, and you get negative 2 over 3. Okay, that's going back to coordinate geometry. But this is like, if you use financial maths and stuff like that, financial maths just solves more difficult simultaneous equations. If you ever see where anytime two functions cross over, you're looking for this point. This is the point where we're talking about in all these things. These are both just lines. So we're starting off quite like they're both lines. Where they cross has an x value and a y value with the y and the x-axis. So it has a visual representation as well. Okay, so let's do the other method of elimination. A simple example, 4x plus, is that 3y I think over there? 3y is equal to 2. And x minus 3y is equal to 8. Is this the first time you're seeing simultaneous equations? No. You should have done them last year. Do you remember this elimination style? Yeah. Okay. I've written it like this because I can just add these together. If it's the same x and the same y, if I add these two together, I have, well, in total I have 5 x's, and what happens here, I have no y's. 3y take away 3y means I have none of them. And that equals 10. And x is equal to 2. Look how easy that is. And then, once I know x is 2, I can use either one of these equations to find out what y would be. Maybe use the second one. X minus 3 times 2 is equal to, no, sorry, x is 2. 2 minus 3 times y is equal to 8. And I need to know what y is, so I subtract 2 from both sides maybe. Minus 3y is 8, subtract 2, which is 6. What's y going to be? Negative 2, yes. So there's always, in these simultaneous equations, there's always two answers, one for x and one for y. Of course, this is a simple example because at the start, it cancelled out. We eliminated the 3 y's because they are opposite signs, so when we add, they just cancel out. What happens if they're not? This is the last example I'll do. 3x plus 4y is equal to 14. 4x plus 5y is equal to 17. The problem here is if I add down, I'm just going to get 7y, or 7x, 9y is equal to 31. That didn't solve anything. It can't just go x equal to. So what can I do? Does anyone remember what we do? You make them equal, yeah. Yeah. So is it okay to times an equation by a number? Like, can I just multiply this by 3? Have I changed it if I multiply it by 3? No, but does it make sense that I haven't changed? It kind of feels like I have changed it. How have I changed the answers? Well, okay, let's think of something. Let's think of 2x is equal to 7 as an equation. If I double both sides or multiply everything by 2, 4x is equal to 14. Does that give me the same answer as I got before? Yes, maybe I'll make it an even easier one. 2x is equal to 6. If I double both, do I get the same answer? Yes. If I multiplied it both by minus 3 now, I get minus 12x is equal to minus 36. Is it the same answer? Yes. So as long as I multiply everything in an equation, I get the same answer. So I'm going to multiply everything in this line by something, and I'm going to multiply everything in this line by something, so I get one of these, where either the x's or the y's cancel. And I pick which one I'm going to cancel. I'm going to say, I'm going to make the y's cancel. I'm going to make sure they cancel out. And I'm going to say, this is equation 1, this is equation 2. I'm going to take equation 1 and I'm going to multiply it by 5. So I get 15x plus 20y's is equal to, what's 5 times 14? 70. Why on earth did I pick 5? Is he? It's 5 as well? It's 5. But if I wrote this second equation down, I'm going to get 5y, and they don't cancel still. Exactly. Lowest common multiple. Very good. It comes up again. Lowest common multiple of 5 and 4. The first thing they both divide into is 20. So I make them both 20. I could have picked 100 if I want, but 20 is the smallest one. So if I multiply by 4, I get 4x plus 20y is equal to 4 times 17. Winston knows. 4 times 17. Come on.
41. He told me to say 41.
68. 68. Oh, that's 16. Sorry, that's 16. Problem. What's my problem, though? What's my problem? Tell me my problem here, mathematically. 20 and 20 make 40. They don't cancel each other out. This canceled out.
Yeah, you got to times by minus.
I should have times one of them by minus. I should have used minus 4. So make that minus 20, minus 68. Now these cancel. Now these cancel when I go down. 20 take away 20 of something is nothing. 15 take away 16 is minus 1 of it. 70 take away 68 is 2, not minus 2, 2. So what's x? Negative 2. X is negative 2. How do I finish this then? We're nearly there.
You gotta put it one of the...
Yeah, which one?
Just which one?
Either doesn't matter. You pick the easier one. Pick the first one. 3 times negative 2, so this is equation 1 again, plus 4 times y is equal to 14. I should be able to solve this pretty quickly. What's y? That's going to be negative 6, add over. That's going to be negative 6. This is going to be negative 6, yeah? He's still with 2, okay. 4y is equal to 14. Add 6 to both sides. 4y is equal to 20, y is 5, yes. Unbelievable. We got there. Okay. Okay. So we'll pick it up here. This starter tomorrow is going to have simultaneous equations in it. So if you want to practice, you can. If you don't want to. But I will be checking your homework. Warning. This is going to be, if you don't have it done, manage back note. If you're not here because of the thingy, that's okay. Oh, those who weren't here can have their tests, yes.
If I guess.
Leave your book. No, I'll just check it tomorrow. If you're doing soccer sixes, I'll check it on Monday. Anyone who didn't get their test, I'm going to give them now. Check manage back. And don't come into class with chewing gum again, Winston.
What if we get sick? What if we...
If you get sick, anybody else see their test? It's a 6. I don't know why I didn't write it. Trinity. Yeah, you can go. Okay, make sure your chair is under your desk before you leave, and you can go.